You are welcome back. We are still continuing the Theorem 7. So this is the continuation of Theorem 7. So in our previous video, we have already looked at 2 videos on Theorem 7. So we proved that T1, or we showed that T1 is equal to what? T2. So this length, we showed that this length PB is equal to this length P T2. Okay? And then we also show that these two angles are equal. S is equal to Y, because this is the line joining the center to the point P outside the circle divides the angle between the two tangents into two equal parts. So far, that is what we have shown. So now we are coming to work on this. We are coming to show that T1 is equal to theta 1. Sorry, we are coming to show that theta 1 is equal to theta 2. Okay, so we are saying that. So this is what we have already done. This. So see, also from triangle BOP. From triangle BOP, sorry, from triangle BOP, triangle BOP, this is sin theta 1, not the sin theta, sin is what? So, as I said, so opposite over hypotenuse, so opposite the side of the triangle facing the angle is what? T1, and then the hypotenuse is what? Is L. So from this triangle BOP, sin theta 1 is equal to T1 over what? Over L. Then theta 1 is equal to T1 over L. Then if you want theta 1, then theta 1 is equal to sine inverse of what? T1 over L. Which is equal to what? Sine inverse of T2 over L. Why? Because we know that T1 is equal to what? T2. So if T1 is equal to T2 and theta 1 equals to sine inverse of T1 over L, then we can say that it's equal to what? The same as what? Sine inverse of what? T2. Because T1 is equal to T2. So where T1 is, you can put T2 there. T2 over what? Over L. Fine. So this is what we have got. So let's note to this. And then also triangle from triangle AOP, this triangle. We are looking at sin theta 2. So sin theta 2, so opposite is what? T2. The line facing the side of the triangle facing the angle theta 2 is what? T2. So sin theta 2 is equal to what? Opposite, which is T2 over hypotenuse over L. So if you want this theta 2 will be equal to sine inverse of what? T2 over L. Sine inverse of what? To be sine inverse of T2 over what? Over L. And then since T2 is equal to T1, then we can say it's also equal to sine inverse of T1 over what? L, because since what? As we have said, since T2 is equal to what? T1. So where we see T2, you can put T1 there. So that is. So we have to note this. Have you seen? So from here, from this side and this side. So let us continue. So that is theta 1 is equal to sine inverse of what? T1 over L, which is equal to what? Which is the same as sine inverse of what? T2 over L. And theta 2 is equal to what? Sine inverse of T2 over L, which is the same as sine inverse of T1 over L. What does it tell you? And hence we can say that theta 1 is equal to theta 2. So therefore, theta 1 is equal to theta 2. Theta 1 is equal to theta 2. Fine. So we have shown that this angle is equal to this angle, and then S is also equal to 1. So this tells you that, as I was saying, that the line from this point P outside the circle to the center, the line that joins the point P outside the circle to the center of the circle, divides the angle into the angle of between the two tangents. The angle between the two tangents into two equal parts. And it also divides the angle between the two radii at the center into what? Two equal parts. Theta 1. So theta 1 is equal to theta 2, and S is equal to what? Equal to Y. Fine. So we are also considering the quadrilateral. We are saying now, AOP, this is what? Is a quadrilateral. So what does it imply? Since the quadrilateral, if you add all the angles in the quadrilateral, you get 190 degrees. If that is the case, then we are saying that theta 1 plus theta 2 plus, so this is theta. We are adding all the angles in this quadrilateral. So all the angle, this angle, this angle, and this angle. So we have theta 1, this angle theta 1 plus theta 2 plus this 90 degrees plus this 90. So plus 90 and then plus 90 plus what? Plus S plus Y will give us what? 360 degrees. That will give us what? 360 degrees. And then so we are saying that so 90 plus 90 will give us 180. So we can say that theta 1 plus theta 2 plus 180 plus x plus y is equal to 360 degrees. Have you seen? So we group like terms, not that per se. So let the variable be on one side and then the numbers also or the angles be on one side. So we say that you can say that theta 1 plus theta 2 plus x plus y, then we send 180 to the other side of the equation, becomes negative. It's equal to what? 360 minus what? Minus 180. Have you seen? Then 360 minus 180 is what? Is what? 180 degrees. Because 180 plus 180 will give what? 360. So hence, you can say that theta 1 plus theta 2 into bracket plus x plus y is what? Is equal to what? 180 degrees. As I was saying. So that is it. This is very simple. We don't have to memorize this. Because this is 90 and this is 90. If this is 90 and this is 90, these two angles will give us 180. So in the quadrilateral, the total angles must give us 360. So if these two angles are already giving us 180, then the remaining angles must also give us 180, because 180 plus 180 is what? 360 degrees. So if this angle is giving us this 90 and this 90, their sum will be 180. Therefore, theta 1 plus, if you add this whole angle, which is theta 1 plus theta 2, to this whole angle, which is x plus y, you get what? We have to get 180 degrees. So that's what we are saying here. That hence, theta 1 plus theta 2, which is this whole angle, plus x plus y, this whole angle is equal to 180 degrees. This is very powerful. So notice this, we said it. So this is the proof. We have proved that the sum of these angles, this angle and this angle, is equal to what? 180 degrees. Let's also note something. Have you seen? Look at this triangle BOP. If you look at this triangle BOP, this is 90 degrees. In a triangle, the sum of all the angles must give what? Give us 180 degrees. So if the sum of the angles in a triangle gives us 180, then it means that this is already 90. If this is 90, then we know that 90 plus 90 will give us what? 180. So if this is 90, then this side theta 1 plus s must give us what? Must give us 90. Have you seen? Theta 1 plus s must give us 90. So that when we add that 90 to this 90, we get 180. So that's why we are saying that theta 1 plus what? S must give us is equal to 90 degrees. In the same way, if we consider triangle AOP, then we can say that since this angle is what? 90 degrees, it means that this is a triangle. So if we have 90 degrees here, then the remaining angles must sum to what? 90. So that 90 plus 90 will give us what? 180. Okay, the sum of the total angles what? In a triangle. So it means that theta 2 plus 1 must also give us what? 90 degrees. So that's why we are saying that theta 2 plus y is also equal to 90 degrees. So you see, students, this is not difficult at all. It's very understandable. I hope you are following and you are enjoying. Thank you. Don't forget to subscribe to the channel. Don't memorize. Get understanding. Don't memorize. See you in the next video. Let us note. So this is just an explanation of what we have just said. This is just we are trying to write what we have said in West. So we are saying that one, that is what? That is the line joining the point P. So this line joining the point P, this point P, outside the circle, where the two tangents meet. So this is the line joining. This is the line joining the point P outside the circle where these two tangents, PB and PA, meet. To the center. So the line joining this point P outside the circle to the center of the circle. Always what? That's what divides the angle between the two tangents. Between the two tangents and the angle between the two radii into what? To two equal parts. This we have already said. So this is just a repetition. We are trying to put it in writing. So we are saying that this line, the line joining this point, which is outside the circle, and then to which or from which the two tangents are drawn, to the center of the circle, divides the angle between the two tangents, this angle, to two equal parts, and the angle between the two radii, this angle into what? Two equal parts. So what we are saying that this is just, we have put what we have said in writing, that s is equal to what? S is equal to y. This angle is divided into two equal parts, and what? Theta 1 is equal to what? Theta 2. So what we are just saying here that is that because the line is dividing the angle between the two tangents to two equal parts, this angle, then s is equal, this angle is divided into two equal parts by this line. Therefore, s is equal to what? Y. And then since the same line is dividing the angle between the two radii into two equal parts, theta 1 and theta 2, then we are saying that since the angle is divided into two equal parts, theta 1 is equal to what? Theta 2 as we have proved. So this is what we have, what we prove mathematically is what we have put in writing. And then we are saying that the angles between the two radii and the two tangents are to what? 180 degrees. So this is the angle between what? The angles between the two radii. So this angle and this angle, these two angles, they are to 180, because we have already said this is 90 and this is 90. 90 plus 90 will give you 180. But this, don't forget, this one is a quadrilateral. So if this side, these two angles are giving us 180, then surely this angle and this angle must give us 180. So that 180 plus 180 will give us what? 360, which is the total angle, angles in what? In the quadrilateral. Therefore, we are saying that the angles between what? The angles between the two radii and the two tangents are to what? 180. So this is what we are saying. What we are saying here is this one. We are just putting what we have said here into writing. That theta 1, if you add theta 1 plus theta 1 to theta 2, sorry, if you add theta 1 to theta 2, and then add this, that one give you this whole angle, and then we add s to y to give us the whole angle. So theta 1 plus theta 2 into bracket plus what? S plus y must give us what? 180 degrees. So that is what we are saying. Thank you guys for watching. I hope you are enjoying. So when we look at examples, you will really enjoy and see that you can have fun with circuit theory. In fact, it's not difficult, as I was saying. It depends on your teacher, the one who teaches you. You can enjoy. I think you are following this video. Hope you are following. So don't forget to subscribe to the channel, get understanding, don't memorize, and then hit the bell notification icon so that when I upload additional videos, you get notified. Thank you for watching and see you in the next